Hi, my name is Kuna Fertingo and I am participating in Challenge 2014. The problem I chose to solve is problem 8 from the Math 1000 problem set. I've already written out all the steps to the problem, so we're just going to discuss each intermediate step. To begin with, we need to understand what type of problem that we're trying to solve. This problem is considered a related rates of change problem. This form of problem is considered by looking at a particular scenario to see what type of change, whether it's a rate or a constant, could have occurred when another factor within the scenario is changed. After reading the problem fully through, the best way to start answering the problem is to look for the known unknown variables of the problem. By looking at these components, we know what we have and what we need to find, which could be changing factors, making it a rate of change problem. So we begin by charting our known and unknown values. So I created a chart here, and as we begin reading, we find that the volume of a sphere of the radius is V equals 4/3 pi r cubed, so we put this on the known side. As we continue reading, we find that the balloon is being filled with a gas at a rate of 25 cubic inches per second. The key word in this part of the reading is rate, because the rate of the volume is changing due to a certain factor. Since the volume is changing over a certain time, we denote this change as dV over dt because the volume is changing over time, aka seconds. It's important to know which is the volume, which is for V, and which is the rate at which the volume is changing, which is dV over dt. As we continue reading, we need to know how fast the radius of the balloon is changing. Changing is another way to say rate, so we are looking at the rate of the change of the radius, which would be denoted as dr over dt, r representing the radius, and in this case it is changing over time, making it a rate over time. This would go on the unknown side because we do not know what dr over dt equals. However, we do know what the radius equals, which is 18, so r would go on the known side, 18 inches. We now have a visual of our known and unknown, and we now know what we're solving for. The rate of the change of the radius, dr over dt. To begin finding what dr over dt equals, we have to utilize the formula, V equals 4/3 pi r cubed. The initial formula will not solve the problem because it's missing our known value, dV over dt and dr over dt. To get the variables in the formula, we must use the chain rule because this will help to get the derivative of the radius with respect to the volume. A derivative shows how a specific quantity changes with respect to another quantity. So in this case, we're talking about how the radius has changed with respect to the volume. So we will now have to use the chain rule to derive the radius because we are solving for its rate. So while we're solving, we're going to be solving in terms of the radius. We also need to denote the change in volume as dV over dt because of the fact that the rate of the volume is changing. So when you rewrite the formula, it would be dV over dt equals a certain number. So now while we are going to derive the radius with respect to the volume, by doing the chain rule with respect to the radius, you need to bring the exponent 3 to the front like I did here, because of the power rule. And then as you continue writing the problem, so we continue writing 4/3 pi because these are both constants, so they do not change. The r will change, however, because as the exponent was moved to the front, the r has lost one exponent, so it would go down to r squared to follow the power rule. We are not done because we now need to derive r, however. We finished with the exponent, but now we have to deal with r, and which in this case will become r prime. R prime is where the change in r with respect to the problem. Change being dealing with rate, so it's in actuality just dr over dt as r prime, as I brought this arrow down to show that r prime is just the same thing as saying the change of r with respect. So change rate dr over dt. After simplifying the problem, so by canceling out the 3's because they are opposites and multiplying to division, they'll cancel to 1, you're left with dV over dt equals 4 pi r squared times the rate of the radius when it changes, which is dr over dt. Now this is just a basic algebraic problem where we solve for dr over dt by isolating the variable because it's the only variable unknown in this simplified problem. So by dividing 4 pi r squared over dV over dt over 4 pi r squared, we have it equals dr over dt, making it a simple equation. And also now it parallels our known to our unknown. So it looks just like we have all our known values and our unknowns. So now we just basically solve by plugging in what we do know. So dV over dt equals 25 inches cubed per second over 4 pi, r equaling 18 squared. And R is in inches, so we have to make sure we keep units the same. So as we solve that out. 18 squared times 4 is 1,296. We left the pi alone because, again, it's a constant, so you can just leave it as it is to keep it more simplified. And it's 25 over 1,296 inches squared per second. It became inches squared per second because an inches was divided out initially, so we are left with this for our units. So this is our final answer. Thank you.